Now to compare the abstract classes with the interfaces, we can say that an interface cannot implement any methods, whereas an abstract class can. Interfaces where all the methods are abstract. We talked about this earlier that we can declare and implement methods in an abstract class, but we only declare methods in an interface, and those all of those methods will need to be implemented by the classes that implement that interface. A class that implements an interface must either provide definitions for all methods or declare itself abstract. Classes can extend only one class but can implement one or more interfaces, and we discussed this in our previous slide as well. Unrelated classes can implement the same interface, and we'll look at this in an example. Interface. So if we look at the comparison, a concrete superclass use extends to make subclass. When we have an abstract class can have methods or at least one method that is abstract. Use extends to make subclasses. But when we have completely abstract class, that is a class that has all of the methods as abstract, or for example interface, then we create a subclass by using the implements keyword that implements this interface. So interface in an unrelated classes. An interface is often used when disparate classes or classes that are completely unrelated, and by this we mean that classes that cannot be combined in an inheritance relationship. These classes have nothing in common except that they do need some functionality that is required to be used in both of these classes. So if these two unrelated classes need to share common methods and constants, it allows objects of unrelated classes to be processed polymorphically by responding to the same method calls. You can create an interface that describes the desired functionality, then implement this interface in any classes that requires that functionality. And we look at this in an example that we can implement the same interface in completely unrelated classes, and we can then polymorphically connect those classes, the objects of those classes. So let's look at an example. We have in the first design, we are given a family of classes, and polymorphism allows us to treat a subclass object as if it were a superclass object. We have a cup class that has a coffee cup as its subclass, and then we have coffee mug and espresso cup as the subclasses of the coffee club. Now we create a single method that could wash any kind of a cup in our, let's say, a virtual cafe. So we pass the cup to this method and it calls a wash method. In this case it is a prepare a cup method. It calls a wash method on that object and the object is washed. A prepare cup method can invoke wash on many different objects of the cup class or any subclasses of the cup class. So we can implement the wash method in the cup class, and we can extend the coffee cup and implement the wash method in the coffee cup class or in the coffee cup class itself that extends the cup class. Coffee mug extends coffee shop cup. So the problem over here can be that now in this case all of these classes are related to each other and are combined in an inheritance relationship. Now what can happen is, what if we want to have a method that can wash any kind of an object, washable object. So let's say we have a window, or we want to wash our car, or we want to wash a dog. Now none of these objects can possibly be subclasses of the cup class. And the problem is that the implementation of wash methods is provided in the cup class or any of the subclasses of the cup class. Now one way would be to try and maybe possibly use polymorphism, which is not possible over here. Maybe we can use typecasting, where we are trying to convert one object of one class into another class and then try to call the wash method of the cup class on that object, as we are doing over here. So we have a situation where we have completely different classes, and all of those classes are trying to call and use the same wash method. But this doesn't seem to work because all of our objects do not fit into the same families. In simple terms, we cannot use inheritance over here, and we are not possibly using polymorphism over here, and it makes things quite complicated for us. Instead, we can use any object oriented technology. For example, in the third case, what we can do is we have four classes: cups, cars, windows, and dogs are combined into the washable object family. So we have a superclass washable object, and all of these are now subclasses of the washable object. Although it does not make sense, but since we can use polymorphism over here, so let's see what should happen. Now, full benefit of polymorphism polymorphism in the clean object method. What we do is we declare the wash method as abstract, and the washable object class becomes an abstract class, and we are trying to combine windows with the cups, and the cars with the cups, and the dogs with the cups, and all with each other. So now the class window extends washable object, the class dog extends washable object, and we can call the wash method on any object of the washable object class. However, something is not clicking over here. It doesn't seem to make sense that washable object is used as a name of the class, since by definition we said that our classes can be noun. Those are objects, and a class is kind of a framework for an object. Now, what exactly is a washable object? What does it one look like? Washable is an adjective. It's not a noun. It describes a behavior exhibited by objects, not an object itself. So this does not make sense. Now, how can we improve the design? Is by using interface. So we create a washable interface. Interfaces in Java allow you to get the benefits of polymorphism without requiring you to build a singly inherited family of classes. Now, if we were allowed to use multiple inheritance, maybe possibly we could have take advantage of that. But Java allows us to use interfaces. Although a class can extend only one other class, it can implement multiple interfaces. And a possible solution can be that an object class that is a superclass of any class in Java. We have a washable object interface. Now this interface can be implemented by all of these classes, and these classes are now, as you can see, we do not need to have a combined superclass, although the object classes a superclass for all of our objects implicitly or classes implicitly, but we do not need to combine the cups with the cars in the same family or cars and the animals with the same family. So family of classes for cups, another for example for animals, one for vehicles. You can include different types of cars over here, one for parts of building, etc. Let's say window, doors and other items. Each washable class can now implement the washable interface. Extending interfaces. Interfaces can extend other interfaces, which brings rise to sub-interfaces and super interfaces, same as the subclasses and the superclasses. Interface extends interface, but a class cannot extend an interface. It should be extend because classes only implement interfaces, so there is no need to extend the interfaces. Unlike classes, however, an interface can extend more than one class at a time. An interface can extend more than one interface at a time. This need to be corrected, that an interface can extend more than one interfaces as opposed to the classes. So we have a public interface displayable that extends a drawable and printable. Additional constant as an abstract methods may be included over here, but when you extend the other interfaces, then all of the methods and the constants of those interfaces are extended into this interface. Another good reason to extend interfaces is the interfaces cannot grow. And as we discussed this problem earlier as well, that think about when you add methods to a class that is already being used by other classes. It doesn't affect them really. They can still use your class just as before. So for example, we have a superclass, and that superclass is inherited by some of the subclasses. If we add a method to that superclass and implement that method in that superclass, it does not really affect our subclasses. We do not need to implement that method in our subclasses unless that method is declared as abstract, in which case the class will always also need to be declared as abstract. But in common situations, in simpler situations, that will not affect our subclasses. But in interfaces, if you add a method to an interface, you break the classes that use this interface, since they now must implement another method. So for example, you have maybe 1,000 classes that are implementing an interface, and you add another method to that interface. Now what you should do is you will need to change all of those 1,000 classes in order to implement that one method that has been just added to your interface, and this can be a problem. So here we can use, or we can extend the interface instead of adding another method to it. So when something else is required in an interface, it is best to extend that interface, add the new method, and then use the new sub interface. For example, we have an interface bounceable that we used earlier, and now we have added a new method to it. All classes that implement the old bounceable interface will break because they don't implement all methods of the interface anymore. And that is a requirement, as we said, that this is an agreement between the classes and the interfaces that implement that interface. They write an agreement that they will implement all of the classes of that interface. So we have public interface boxable, that was from our earlier example, and now we have added a new method to it. Public class basketball implements bounceable. It was no add method is defined in the basketball, it will have a compile time error because now it needs to have the add method. Solution: write a new subinterface. So we have a public interface bounceable and we do not add the method to it. Instead, what we do is public interface bounceable plus extends bounceable. Now users of your code can choose to continue to use the old interface or to upgrade to the new interface. Now what happens over here is that even if we are using the bounceable interface, that has not been changed. As we can see, this will not affect our this class since the bounceable interface has not been changed over here as opposed to this situation. What has been done is the public interface bounceable plus, we have created a new interface, that is the bounceable plus, that extends the bounceable interface. Now we will only need to implement this add method in our class if we implement this new interface. And this is where we have avoided a situation that can break our program if we were to add a new method to an interface that we were already implementing. And what alternative we can do is we can create a new interface that extends our old interface. And now if there are classes that need to implement this new method, those classes will implement this new interface. And so for example, we had 1,000 classes which were implemented or implementing our old interface, and now 100 of those 1,000 classes need to implement these methods. We will only need to change those 100 classes and we'll leave our 900 classes as they were already. So this is an advantage where we can use extending the interfaces. Now the typing rules for interfaces are similar to those for classes. A reference variable of an interface type T can refer to an instance of any class that implements interface T or a subclass or a sub-interface of T. It is the same as when we inherit a class or when we inherit from a subclass of a superclass. We are able to create an object of the subclass using the superclass reference. We can use the interface reference to create our objects of for the classes that are implementing that interface. Through a reference variable of interface type T, methods defined by T and its super interfaces can be called. So it is exactly the same as our classes, and we'll look at it in this example. We have an interface that has two methods, in this case I1, interface I2 that extends I1 and has its own method as well. We have a class C1 that implements I1 and it implements the methods of the interface I1. We have a class C2 that implements I2, so it needs to implement all of the methods of I1 and I2. Now when we create objects, C1 A is an object of the C1 class, B is an object of the C1 class. What we can do is we can create a variable, a reference variable, and we can assign this object of the class that implements this interface to that variable. So we can create a declare a variable using our interface, and this is called now a reference variable. This P will be called a reference variable, and we can assign this object to our reference variable. Now we will be able to call these methods m1 and m2 using the reference variable of our interface, and it will call the m1 method implemented in the class C1, and this one will call the m2 method implemented in the class C1, M2 method in class C1. You can check for the case of the classes. This should be the same. There's a mistake in the slide. Similarly, if we declare an object of class C2, what we can do is, let's say we have a reference variable declared using the interface I2. We can assign the object to that variable, and we can call the methods of class C2 using this variable, and this is the same as we can do with our classes and polymorphism. A is a reference variable of type C1. P is a reference variable of type I2. So A is basically an object of class C1, and P is a reference variable of type interface I1. The same as Q is a reference variable of type I2. We can also use the instance of operator. You can use the instance of operator to test an object to see if it implements an interface before you invoke a method in this interface. This might improve readability and correctness. This might be a hack. Where possible, you should extend classes and interfaces to obtain polymorphic behavior rather than making a runtime check. So we can use the instance of operator, but alternatively we can explicitly extend those classes interfaces instead of checking them at runtime using the instance of operator. If B, for example, is an object of any class that implements the bounceable interface, we should be able to call the hit wall method of that class using the object B. And finally, we'll look at the final variables, methods, and classes briefly. The final keyword can be applied to prevent some of the inheritance effects. Now, when we use inheritance, we said that all of the methods and the data members of the superclass, especially the non-private ones, are inherited by the subclass. Now there might be situations where we do not want to allow everything to be inherited by the subclasses. In that case, we can declare those fields as constant by using the final keyword. A final argument cannot change the data within the called method. So if we declare a parameter as constant or as final in Java, then we cannot change the value in that variable wherever we call that method from. A final method cannot override method in subclasses. A final method cannot be overridden. So if we want to prevent a method from being overridden by the subclasses, you can declare that method as final. Let's say we have a method that has been declared as final. Now if a class inherits this class, then that class will not be able to override this method or re-implement this method. A final class cannot be subclassed. So if we want to prevent a class to be from to be inherited, then you can declare that class as a final class, and all of its methods are implicitly final as well. There might be situations where you might need the final classes, and those classes can then not be inherited. So finally, you can look at this example. You have an interface that has some methods. Write a person class which implement the two interfaces. The implementation should be very simple, just a print ln statement in each method. So we have two interfaces and you need to write a class that implements these two interfaces, and by that we mean that this class, the person class, will have to implement all of these methods. So this is just a very simple exercise just to get you started. We will look at an example maybe in the next videos to how to use interfaces in our programs. So see you in the next video.